Hello and welcome back to Leilani Electronics. Before we get into this next circuit, go to the website www.leilaniElectronics.com. There's schematics, programs, other awesome projects up there. Like and subscribe to the channel. See more videos. I'm trying to put a video up more frequently than I have been. But the circuit we got right here is a PIR motion counter. It uses a PIR motion sensor, which detects motion. This is the module right here, this little guy right here, and that's part number, it's a Panasonic part number AMN12111. Now, PIR stands for passive infrared. So it'll detect motion. If you look at the data sheet, most of them will give you a field of view. Like this particular one says the field of view is 90 degrees. That means it'll detect motion, sense motion in that field of view up to 90 degrees. Anything beyond that, it probably won't pick up. So when I turn it on, it'll start, detecting motion and me waving my hand or this pencil. And the output is digital. They have them in analog where you can get an analog output, but I just went with the digital output, which will give you a pulse every time it detects motion. It's idles low, so every time it detects motion, it'll go high and back to low every time it senses it. All right, so I'm gonna turn it on, and it'll probably start scrolling through all the LEDs. I have it set up so it'll scroll through 47 LEDs, and on the 48th pulse, these two 10 millimeter blue LEDs will start flashing as an alarm to let you know that it reached its maximum count. This could be good for floodlights, a hallway sensors, door. Like I had something like this set up for my cat. He keeps going in the kitchen. He's not supposed to, so I can keep track of every time he tries to sneak in there. And when this alarm goes off, I know how many times he tried to peep his head in there. Circuits like this could be used for Halloween props. Like when you do the jump scare, they all use the same, most of them use the same setup. It'll just detect motion, pop up, jump scare you. It could be used for Christmas lights, anything like that. So let me turn it on. We'll turn it on right here. You see it start out with 1. You see how fast it's going through. The reason it's toggling so fast is because the field of view of this particular sensor, like I mentioned earlier, is 90 degrees. So I'm gonna just let it go through its count, and then when it triggers, when it gets to the last count, you'll see these two guys start flashing back and forth. And the only way to reset it is if you push the reset button. See, it's almost there. We'll wave around some more. Yeah, there we go. There you go. So now this will trigger an alarm. You can have any type of alarm output, a buzzer. I just put 2 lights on there just for an example. So I'm going to reset this, but after I put this coupler, got this coupler from doing some plumbing, and what this coupler will do, if you sit it right on top of that guy, it will narrow the field of view so it won't trigger as much. And like I said, you could put this in a hallway, doorway, outside. That way it won't trigger too many outside interferences. It'll just, when somebody walks past it or something, bird flies by it or whatever, it'll toggle. So I'm gonna hit the reset button. And if you notice, it's not triggering as much. That's because I limited the field of view to basically like a narrow beam. So when I wave my hand over there, there it is. And you see, you just keep, I'm doing stuff in the back above it, so it's picking up all that. But if I get away from it, it'll stop. See how it stopped? Now when I get close to it, it'll just keep pulsing. Every time it picks up a hit, it'll send a clock pulse out. Okay, it's almost at the end. Now if I take this off, and it's going to get there pretty quick. And again, this comes in analog, but I chose a digital. If you do go with the analog, you may need like a A to D converter into a microchip, or some form of way of determining what the analog voltage is. That's pretty much it. It's the PIR Motion Sensor. I have another module here that I got from Parallax. Same concept, 3 pins. It'll give you, high output every time it picks up motion. So we're going to go over the schematic, and I'll show you how all this works. Okay, so here we got a printout of the schematic. You can go to the website, print this out, have your own copy. I'm going to go over it on my computer. Before we get into the schematic, anytime you're dealing with a lot of different type of logic gates, I have this book, the TTL cookbook. I have a CMOS cookbook. I've been using this guy for years. If you flop through it, it'll give you, there's about 100 different type of gates to tell you how they operate, how to use them, because there's a lot. So let's get right to it. Here's your, let me move this over. There we go. Okay, there's the PIR module. I got it going into a transistor. When it goes high, it turns the transistor on and clocks a 7493. That is a binary counter, 1 of 16. I have 2 of them cascaded in series to give me my 48 outputs. And those are tied into 3, 7, 4, 1, 5, 4, 1 of 16 counters. And I also have those cascaded in series to give me the 1 of 48. So every time this gets a clock pulse, it'll increment this counter from 1 through 48. And that's how I'm getting my LED outputs. The flashing circuit on the last output is not connected, as you can see, to an LED. That's where I get my alarm from. Right here. Then that ties into a JK flip-flop. So when this last LED is active, it pulses this JK flip-flop, which takes the Q and not Q and flops them. Whatever state they're in, it just toggles it. So now, when it toggles the Q, it goes into an inverter, which now disables these 2 binary counters. So that's why the counter stops and doesn't continue to count while the alarm's on. And then this output is high, which enables the transistor, which gives power to the LEDs, and this is your flashing circuit. They go back and forth. If you want them to go faster or slower, you just increase or decrease these capacitors. Then when you hit the reset button, it resets the JK flip-flop. These 2 outputs toggle. Now these are enabled, and this guy's off. The lights turn off. And that's pretty much it. Let me see. Oh, here's a power supply, 7805. I use that for all my TTLs. Input protection diode, on and off switch, and all your bypass capacitors. Got to make sure you use those. And that's it. Go to the website, print it out. I hope you liked it. I'm gonna do another video on the surface mount. I also did this in surface mount because, again, if you don't want to program, you can do it this way, or if you able to program, you can get the same. You just get a digital readout from this guy, which I'm going to do another video on this one. So go to the website, print out the schematic, go build it. Hope you have fun. Set it up. Let me know what you think about it. Like and subscribe to the channel. Drop me a line. Thanks for watching.